So we're going to transfer from what you might call triangular geometry to circular reference of angles. So we're moving towards what I would maybe call circular reference of angles. And what I really mean by that is we're working towards drawing angles in relation to some circle like this, where you got an XY plane like this, but what we're drawing is we're drawing a circle that goes along like that. And we're talking about referencing angles off of that. So where, think about the angle measures, we're going to call this 0 degrees. And if you go all the way around the circle, we're back at 360 degrees. Now, we're always going to be moving that in a counterclockwise direction. So this is 90 degrees. This is 180 degrees. So all triangles measures are going to be within those. This is 270 degrees. And then we're back to 360. If you're a skier or a snowboarder, you know, when they talk about a 720 or a 1080 or something like that, that's what they're referencing. How many times did the individual rotate? So we're talking about this rotational reference angles. So we're talking about angles made using rotation. I want to talk about the quadrants. So there's 4 quadrants in this diagram. This is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. It's always again in a counterclockwise rotation. So when we're talking about the reference angle, I'm going to define it in a really specific way, and if you don't think about it in this specific way, you're going to have really good intentions again and just mess things up. So here's what I want you to think about. Here's what a reference angle is. A reference angle is the acute angle. So when you think about acute angles, that's between 0 and 90 degrees, made with the x-axis, so the horizontal axis, so it's the acute angle made with the x-axis. And we talk about this term reference angle because it allows us to use sine and cosine and tangent and all those things much more quickly. And then we just have to adjust actually signs and things. Couple of things with this is you know, when you think about positive and negative, out here x is positive. We'll talk about that in a little bit. Out here, x is negative. Down here, y is negative. And up here, y is positive. So just think about that. But we're talking about x and y, but we're also talking about rotating around this this circle. So sort of like the spoke of a wheel on a bike. So what I mean by that is you're going to have questions like something like this. Reference angle, find the reference angle for a rotation of 254 degrees. So let's think about 254. That's going to show up right down here, right? So what you're going to do with this is all reference angles are going to be either, you're going to find reference angles in the second quadrant by doing 180 minus the angle. In the third quadrant, let me think about that, how I want to say that. So let's just talk about let's just do an example. So let me back up. Let's just look at this example. If we are going to, you got to kind of just think about, rather than giving you a directions, think about where the angle would be placed. So 254 degrees. If you think about an angle that's placed on a circle 254 degrees, and you think about this being 0 degrees and this being 270 degrees and this being 180 degrees, 254 is going to be somewhere in that third quadrant, somewhere down here. Okay, so this is going to be 254 degrees, something like that. Now, when you think about, it might be closer to 270, but you get the idea that it would be somewhere in that third quadrant. So when you're trying to find the reference angle, and the reference angle is the acute angle made with the x-axis, this is 254 degrees, but the reference angle is this one right here. That angle right there is what we call the reference angle. The reference angle is, if we were going to find that angle, what we would do on this particular one is we would take that 254 and we would subtract 180. And if we did that, you could use a Desmos Scientific. You maybe could do this, and some of you, admittedly, maybe can do this off the top of your head and know that it's going to be 74, I think is what it is. But you could do 254 minus 180, and you'd end up with a reference angle on this of 74. So that's the answer that they're looking for right here. If you look for it, there's the way they're going to draw it. It comes down in that quadrant. You're also going to be talking about what is termed as coterminal. So let's talk about what that word means. Coterminal angles are angles that end, or what you would think of being, that's where the word terminal comes. So terminate at the same place. And that's really where it stems from the word co, meaning together, terminal meaning ending. So coterminal angles would be angles that end at the same place. More than one angle that ends at the same place. So when you think about like this rotation, 889. So if we wanted to figure out, find the coterminal angle here for this angle, think about what that would mean. So think about like drawing that. So example 2, an 889 degree rotation. So if we're looking for an 889 degree rotation, we got to figure out where does it even show up? Where does that show up on our diagram? Think about like what would happen if we go like to there. That starts at 0, then we're back at 360. If we do that again, that's 720. So all of those 0, 360, and 720 are all what would call coterminal angles. If you try to figure this out, you could do 889, subtract 360, you get 529. Take 529, subtract 360, and you're down to 169. So if you think about 169 more, what we're looking at is we're going to go to like right here. This would be 889 degrees. And it's the same thing as 169 because we've just rotated a couple times around. So based on that, that's the same thing as 169. So when you're asked here, it's coterminal with 169, which lies in which quadrant, you should know now that this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. So it's in quadrant 2. And then we get the reference angle. Well, to find the reference angle, if we just take 180 and we subtract 169, we figure out how far short is this angle from that 180. Because remember, this is also 180. So if we were to do that on our calculator, we do 180 minus 169, and we get 11. So our reference angle is 11. And if we were to put that in, you'd see that we got 169, it's in quadrant 2, and a reference angle of 11. So we've spun this around a couple of times. That's what a coterminal angle is. So it's coterminal because it ends at the same space. It lies in quadrant 2 in this case, and it has a reference angle of 11 because we figured out how far that acute angle is from that horizontal axis. That's the type of problems you're going to have to do. You're going to have to also do something like this. Find the angle of each quadrant with the common reference angle. So let's look at what that would look like. If we were to take this one, common reference angle on this, you know that you got 132. So 132, you know that this is 0 and this is 180. And this is 90, so 132 is going to be back like somewhere in this ballpark right here. So if we wanted to find the reference angle, we would take 180, subtract 132, and we get a reference angle. So if I go back to here, I do 180 minus 132, we get a reference angle of 48. So we got a reference angle of 48. So we know that this angle right here is 48. Now, this question is saying, okay, well, talk to me about the other angles in the other quadrants that, that have that common reference angle. So you know that we're talking about this one. You know this one's 132 because that's already in the second quadrant. Well, that reference angle, if you think about it, in the first quadrant, that's 48. So in quadrant 1, the reference angle actually is the angle because all the angles in the first quadrant are going to be acute. If you're trying to find the one down here, this is 48 right here, then we're going to do 180 plus 48 to get this one. So if I go to my Desmos, 180 plus 48, 228. So that's my third one right here, 228. And then my fourth one is going to come over here in the fourth quadrant, where if this is 48, we could do 360, subtract 48, and then we're going to be left with our third one. So if we do 360 minus 48, we'll get the one in the fourth quadrant, which is 312. So go here, 312. You'll see that solution is those four reference angles. And you can see that they make kind of a T there, an X there, and they all have a reference angle of 48. Hopefully that helps. If you have any questions, let me know.